Hello everyone, good morning. So first of all, I'd like to welcome you all for the webinar on revealing the world we live in with realistic MODSIM. So I'm Agastya, a CAE application engineer from Beacon, which is one of the India's largest resellers for Dassault System SolidWorks and its products. So we have been in this industry for over 2 decades with close to 4,500 customer range across the country. So we have our offices in 7 states. So Telangana, Karnataka, Maharashtra, Tamil Nadu, Goa, and Ahmedabad. So coming towards the webinar part. So before we start the webinar, I'd like to ask you a couple of questions so that we all will be on the same page. So kindly do vote these particular polls. Okay, so thanks for the voting. So now we shall stop this vote and let's have another poll. So how many of you are familiar with the concept of MODSIM? So we have another 30 seconds to vote. Okay, so I'll stop the voting process in just a couple of seconds. Yes. Yes, so thank you for all your voting. And now let us start with our webinar. So the concept of MODSIM. So it's basically in order to introduce you the concept of MODSIM, I'll just take you through a couple of videos where you will be getting more awareness on this particular old concept within Unit. And whenever we discuss about combining design and simulation product, so we need to understand that there should be a connector which takes care of modeling and as well as the simulation. So that is the platform what we call as 3D experience. So in 3D experience platform, basically which is trying to connect the design, governance, and the simulation part of it. So it enables innovation, it facilitates innovation, and it powers innovation through the simulation. So basically we are combining CAD, PLM, and CAE domains, everything into a single platform that is nothing but our 3D experience work. So this is a small video about 3D experience platform and the MODSIM approach.
These detours can impact function timeline and simulation. Designing and testing together is not you and what manage distractions and errors, resulting in something that's far ahead of some of the parts. No matter what your challenge or your industry,
So now, why simulation? So basically, in order to understand this particular question, let's have a simple understanding on Truecaller. So why do we use Truecaller? So it has the power of revealing the unknown callers. So whenever we get a call from unknown person, the Truecaller will reveal the actual name and their location. So basically, it's diagnosing and giving us what to expect in the next couple of minutes. So the same goes with the simulation as well. So we do design and validate our product and see what exactly is going to happen over a period of time or over the usage of our particular product. So now, in order to reveal the world we live in, starting from aerospace industry to life sciences, it has wind energy into it, it has electromagnetics part of it, transportation, life sciences, construction, and everywhere. So the simulation is one particular domain in each and every aspect of product development. So what is the current scenario? So the design we mostly choose are basically from gut feelings, experiences from the previous knowledge and calculations, and the physical prototyping. So what are the challenges with this? We are investing a lot of time and money onto it. So in order to reduce basically the time to market, we will go with the MODSIM approach. So these are the consequences of our generic design and development process: over dimensioning, no optimization, and reduced innovation as well. And even the knowledge or the experience, it matters from person to person. If we change the product, if we change the designer in the middle of the project, then there will be a lot of issues because the new engineer might be able to understand this or might not. An endless loop between design and the test. So we will try to reduce all this. And these are the few statements that are provided by the industry heads on why business needs simulation. So simulation allows companies to meet the demands, reduce cost and faster time to markets. It's simply making things bigger and heavier with no longer suffice. So complexity is leading more companies to utilize the simulation portfolios so that they can predict how the products are going to behave in the real world. So we used to make things, break them, and try again. Economically, we just couldn't sustain that behavior by engineers. So this is by Dr. Thab, who is a principal tech specialist from Jaguar and Land Rover. So we just have to move towards the sustainability. We have to reduce the material wastage and the time wastage. So these are the ways where our simulation tools can help in accelerating your businesses. So now let's see what are the real business issues. So the product quality, market share concerns, the new competition, new products in the new market, decreasing in the margins, losing to the competition, delayed delivery, warranty cost. So in order to get the details from each and every of this, so how do we get this particular results from a product without even selling it to the or without even sending it to the trial versions of it? So once again, coming to the MODSIM approach, we will be able to design and validate the products then and there itself. In the sense, in the same window, we have the connectivity between our CAD and the simulation tools to enhance the product quality and decrease the material cost, increase the margins. Any market, any product, we are ready with our validation tools. There won't be any delay in the delivery as we are on dot. So now with the help of simulation, you can use the performance, innovate, performance, optimize, design space exploration, confidence, and you can decrease the cost, time to market, and the risk factors. So this is how, with the help of simulation, the factors which can be increased and can be decreased over a period of time during the new product development process or in improving the existing products. So in this particular video, what we are going to say is how exactly the simulation is going to give us an idea on what are the physical conditions. So here you can see we have this particular disc brakes. So the moment we talk about disc brakes, we will be pushing them to their extreme limits by overloading the speeds, overheating, and even the material properties. So you can simulate all these phenomena and do the optimizations inside the simulation tool. We will go with the lightweight design, performances, robustness, and including the cost reduction. So how would you accelerate this particular innovation? So there is something called as design of experiments, where you will be able to control the parameters and see what are the different types of options that are going to be utilized and that are going to match our objectives. So here we have the design objectives and 4 different models, and then we have our objectives as well: maximum braking force, noise or squeal resistant, minimum cost, and minimize weight. And here we can see the graph over the iterative process, where we can see the mass and the final products. And now we can see on the same particular bike, on the same particular two-wheeler, we have replaced from a thick model to the thinnest model with a better factor of safeties. So this is how the MODSIM approach, and now we can see the improved performance as well. This is how our simulation will provide a power and a key to your innovation. So now welcome to the 3D ExperienceWorks MODSIM platform. So basically we are here to reduce the distance between virtual and real to zero. So this is the first look on 3D ExperienceWorks simulations. So here we can see we have like different types of approaches, design engineers, collaboration between the teams, and what are the different types of applications that 3D experience has. So I'll just take a moment over here. So here we can see the structural, fluid dynamics, plastics, and electromagnetics, as well as the motion analysis. That is our kinematics part of it. So 3D experience platform does support each and every physics that is available for our physical prototype testing. So here we can see the actual working phenomena of drilling the rocks. So here we can clearly see how exactly the deformations are taking place when we take a particular foot and the die punching phenomena. What is the deformation and what are the reaction moments and the spring forces when we go with the kinematics part of it? And what are the factor of safeties? So all the structural validation, including the frequency and the dynamic steps, we will be able to evaluate it inside the solver. And when we talk about the fluid dynamics engineer, we will be able to understand what is the absolute pressure, what is the gauge pressures, and even the velocity factors, the deformation scales with respect to the fluid structure interaction. And here we can see the plastics filling, so multi-shot analysis with different orientations and different fill times. And this is the CST Studio suite where we will be able to understand the E-field phenomena of the electromagnetic radiation, whether it is a standalone product or it is on a complete assembly level. So this is how the MODSIM approach works. Directly you take the model from your CAD model, here it is our SolidWorks, and go to the 3D experience platform where we will be able to optimize it. So in this particular case, we are optimizing the motor with the highest with the best efficiency, at the same time with the least mass. And here we can see with respect to the thermal as well. So we are able to do with two different analysis. One is casing without the slots and with the slots. Here we have the crash test phenomena of a bicycle. So this will So this is how the 3D experience platform is going to connect the approach of modeling and the simulation. Now, in the previous cases, so there was a myth saying that simulation tools are for specialists, hard to use, complex, expensive, limited budget powers, long design iterations. But with MODSIM approach, that is nothing but the democratization of modeling and simulation. It is pretty much powerful and easy to use. 3D CAD integration, there will be fully CAD integration between your CAD software and the simulation software. Quick design changes, so in just a couple of clicks, you will be able to update your design inside the CAD as well as inside the simulation modules as well. It's fast, cost efficient, good result visualization. So in the previous videos, we have seen how good and powerful the visualization of the results are in 3D experience platform. And also it enables cloud computing. So this is one of the biggest advantage with respect to the 3D experience. So whenever we talk about any simulation tools, we will be focusing on HPC implementation, higher number of cores, and then higher number of hard disks, large computational powers. That all can be eliminated by making use of 3D experience. So the complete high performance computational cores or the data can be stored inside the cloud platform and part of the complete product design process. So in this particular approach, we are not going any way away from our 6-step process of design development in the development of a product. So we are sticking to the 6 steps of design and development, and we are continuing with our process without any hiccups. So now, what is basically the simulation? In order to define the simulation, I would like to put it in this way: the product design diagnostic superpower. So in the sense, whenever we have certain ill going on with our body, it can be cold or fever, we will run towards the doctor, and doctor, first thing what he does is he will go with the diagnostic reports. That's exactly the simulation does. So in that particular case, we are going with the blood test or X-ray, and in this case, we are going with respect to the FEA and CFD. So now I have one more poll question where I would like to know about how many people are you familiar or most crucial with respect to your work? Is it structural? Is it computational dynamics? Is it plastics? So we can have this poll for next 30 seconds and then we can continue with our presentation. Okay, so now let us continue with our presentation, and this is our model. So we have a tricycle with the model, and with the MODSIM approach, I was just able to understand what is the deformation and the stresses that are being generated when we apply certain amount of load from the seat towards the handlebar. So it is as simple as that. So now in order to understand about our diagnostics, since we said our simulation is a diagnostics tool, so we can identify with respect to the forces and loads whether it is built to last, in the sense whether is it going to have any fatigue life, metal forming, package process, transportation, mixing and concentrations, and create a performance curve. That's what we have seen. So in the performance curve, what we are going to do is basically we are going to do the trade-off analysis where we will be comparing multiple outputs and see which is the most suitable process for us, and optimization. So you can optimize the model with respect to the thermal management or with respect to the structural management as well, impacts and collisions. So I will just go through a few of the concepts. So here we can see the kinematics motion of cylinder and motors, the mechanisms, and the cycle times, where we will be able to understand the the forces or the stresses that are being generated is not only because of the external forces but due to the internal mechanisms as well. So we will be able to understand and evaluate the same. So there are different types of contacts. So you can have the frictional contact, collision contact, or even the complete non-frictional contacts as well. So maximize the strength and the stiffness is factor of safeties. So once we run the analysis, whenever we design any product, we have a certain regulation saying that this is the minimum factor of safety that we are looking forward. So we will be able to understand and evaluate what is the minimum factor of safety. Are we obtaining our required factor of safety or not when we take this particular product into the real world applications? So these types of understanding the expansions, contractions when it comes to the thermal phenomena and the factor of safety evaluations can be understood in the simulation approach itself, and can be changed if at all. If anything needs to be modeled or modified, we can do it within no time. So it's like verifying number of components. So whenever we talk about the components, especially in terms of the structural analysis, so there will be bolts, lots of connectors, links, bolts, cylinders, and then we have well lines. So are they going to work as per our intentions or not? This is one of the biggest challenge for any structural engineer. So we will be able to make use of the virtual connectors, and we will be able to understand whether this particular connector is going to withstand or sustain this particular operations or not, and the durability as well. So the moment we talk about whenever we buy any particular product, we will be able to see guarantees and warranties on the sheets. So how exactly are they giving you? To just give you an instance, take the example of iPhone 12. Starting from iPhone 12, they have introduced ceramic glass, and Tim Cook has stated that you can drop your iPhone from a feet of 4 feet and there won't be any damage for your iPhone. How did he say so? Did he really drop the iPhone in the beginning itself? Never. He did lots of iterations using the validation tools, and finally he came to a conclusion saying that yes, this is the maximum height where this particular phone will be able to survive. So if at all the phone drops below from the 4 feet, so you can go and claim that something is wrong with this particular product. But if it drops from a 5 feet or 6 feet, then you cannot claim anything because they clearly stated that it's 4 feet. So that's how the companies are going to make use of the durability and fatigue analysis in order to estimate what is its life. And even you can go with the reduced material optimization. So this is in the optimization, we have shape optimization, geometry optimizations, and the material optimizations as well. So we will be able to get the required or the desired factor of safety and the stress concentrations and the distributions with less material utilization. So this is the topology optimization that our solver supports, where we will be able to design or obtain the products that are unimaginable by human. So right here we can see, so this is the initial part over the iterations of topology optimization, and this is what we finally obtained. So you can say that this is the same, or in some cases it has better stiffness compared to that of the initial part. So this shape optimization is going to be very helpful in few cases where we have no control over the parameters that needs to be addressed. And then the vibration loadings. So our solver supports entire range of vibrations, and as well as the dynamic loads like time history, or random vibrations, shock vibrations, and then harmonic vibrations. So we need to understand what are its mode shapes, what are the natural frequencies before we take our product into the dynamic loads approach. So here we can see we are able to understand on the engine mount. So whenever we have this engine mounts, what are its natural frequencies? Whenever the engine works, we have to make sure that the frequency of the engine shouldn't match with the natural frequencies or the eigenvalues of the base band. And then the metal forming process. So whenever we talk about metal forming, we are getting into the non-linearity aspect of the physics. So the complete three types of non-linearity, that is geometry, material, and contact non-linearities, can be addressed inside the Abaqus solver, where we will be able to understand what are the stresses, what are the stresses that are being developed in the sense of internal stresses during the forming process. On the rubber and elastic materials, so it will go through the large extent of complex contacts and the large deformations, and to be very precise, if you have a focus on this particular gasket compression. So here we can clearly see that it's not only the contact is being established between the components, it is within the component. So there is some concept called as general contact, and the self contact, where it will be able to understand that it is within the contact and there shouldn't be any penetration. So with just single step of approach, we will be able to define thousands of contacts, thousands of complex contacts, and make it in a much simpler way. And then we have misuse and overload. So you can do the buckling analysis, crush analysis, and we have like different sets of rigid and flexible body combinations. All these phenomena and the analysis can be performed. And then different types of failure. For example, Johnson-Cook failure methodologies can be implemented. Ductile, brittle material failure phenomena. So this is the case where we perform in the universal testing machine in order to understand the tensile strength of the material. So instead of wasting a specimen, you can just model and apply the same boundary conditions onto the solver, and then you can obtain what exactly you are expecting that particular curve, stress versus strain curve, from the solver itself. And here we can see if at all there is any damage and still the load being proceeded onto the component, we will be able to understand how exactly the propagation of the failure is going to take place. And then we have the package droppers. Instead of dropping a single part or an assembly, we are going to drop the complete package, where you will be able to understand what are the impacts of, say for instance, corrugated box. In this particular case, we have a corrugated box, and here we can see the deformations. And here we have a plastic wrap around the water bottles. So around the water bottles, any PET bottles, we can see what is the stress that is being applied onto the bottles. And these are the cases where we see some of the Kinley and Coca-Cola bottles. We can see that though they are directly from our refrigerators or from the casing, you will be able to see the deformations on the top. How exactly is it? Because of the wrappage. So whenever there is particular excess amount of pressure that is being applied onto the bottle because of the wrap, we can see the deformations. We will be able to understand all these phenomena as well. And then we have the transportation phenomena, where we will be able to understand the movement and see whenever we have the stack configuration. So what is the deformation on the bottom stack, where there will be huge amount of load that is being applied, and during the transportation from one place to the other place, how exactly the things are moving around. And there is a concept of CEL approach and the SPH approach, where we will can make use of smooth particle hydrodynamics and see baffling of the water tanker. With the baffles, how are we able to reduce the sloshing effects? So with respect to the hyperelastic materials, we will be able to perform the analysis, the bending analysis of a pipe and different types of drop test phenomena, where we can make use of the mannequin and then understand what is the contact patch. So where is the impact point on a mannequin, or where is the impact point on a particular object. So different types of collision tests like crash test, bed strike analysis. In this particular case here, we can see whenever there is a bed strike over an aerofoil, over a wing of an aircraft, how exactly it is getting splitted all around the place, and then the collisions. So this is where I was talking about. In the previous case, I spoke about general contact. So just imagine solving this particular analysis by defining the manual contacts. There will be thousands of contacts, and practically it is not possible for us to define thousands. So just enable one single contact, that is general contact, and it will create and it will generate and degenerate thousands of contacts as and when needed. So these are the special contacts or nonlinear contacts, complex, plasticity. So we have seen all this on nonlinear materials. And the best thing about this is there is something called as material calibration. So whenever we discuss about hyperelastic materials, there are different types of Ogden models. And then we have polynomial models. So what is the best suitable model for us to utilize for this particular operation? So the solver will suggest which is the best suitable model by making use of material calibration. And in order to perform material calibration, you just have to do is just provide tensile uniaxial test data and the biaxial test data to the solver. The solver will run multiple iterations for you, and then it will suggest you whether to go ahead with this particular material modeling or not. And the impacts, advanced physics such as implicit and explicit solvers, both are available. Quasi-static solvers. So we have already discussed about the nonlinear problems, where we have seen addressing all three types of nonlinearities: material nonlinearity, geometric nonlinearity, and the contact nonlinearity. So now let's focus on the flow simulation, so where we will be able to understand how exactly is the flow patterns taking place inside or around the products. So the moment we say it is inside the product, it will be very difficult for us to visualize. At least if it is outside, you can make use of during the wind tunnel test. You will be able to understand by making use of smoke. But take in case of valve, take a case of valve over here. So how do we know that where is the recirculation zones? How do we know that where are the recirculation zones? Where are the negative pressures that are being developed? And how exactly is the noise due to the pressure drop or due to the change in the negative pressures? We will be able to hear some amount of noise. So what is the amount of noise that is being developed? We will be able to understand and visualize all these phenomena using CFD tool. So and then here we have the free surface phenomena as well. So here we have the free surface, where we will be able to evaluate how much time does it require to fill the tank, and how much time it takes to relieve the tank, and then tank sloshing effects using flow simulation. And then here we have the HVAC, that is nothing but our mixing in concentrations. So whenever, say for example, during COVID, we were always suggested to wear masks. What was the reason for it? Because if at all there is any COVID affected patient or someone having any sort of symptoms, whenever we are speaking, there is a transfer of the saliva through the air medium. So in order to get over it, we were suggested to wear the mask. But exactly we are going to simulate. So just say for example, if you have a particular sneeze, the moment you sneeze and there is a person, there is an object in front of you, how exactly it is going to identify a particular object and how is it distributed over that object? You will be able to understand with this solver. And then we have the thermal effects. So here we can see the ice cube. So here where we have like two different types of fluids. One is the cold fluid and one is the hot fluid, and we can see the temperature differences and how exactly the temperature is changing because of the effect of hot and cold fluids interactions. So here we can get the performance curves. So here we can see whenever we rotate the check valve, we will be able to stop the flow. But the moment we stop the flow, what exactly is going to happen? What is the force that is being exerted? We will be able to do it making use of what if analysis, that is nothing but our optimization study once again. And here is the one we were discussing about how to prevent the noise. So whenever this is our computer fan. So whenever the computer fan rotates, we will be able to hear the noise. So what is the decibel noise that we're going to hear? And because of the negative pressures or the pressure drops, what is the noise that is being generated and where exactly we will be able to identify the noise so that we can rectify the problem in the future. And also, it's not only about the qualitative approach that we get from these solvers. We will be able to get the quantitative approach as well. So here we can see we just have to select a particular location and we will be able to understand what is the pressure drop. In this particular case, we are going with the pressure drop. And what is the pressure drop at the outlet? That's exactly what we are expecting here. So we can see over the period of iteration, so the period of time, how exactly the pressure drop is varying and is it fitting to our desired data or not. All these can be evaluated. And then you can do the thermal analysis as well. So where the solver is capable of handling all three types of heat transfers. That is our convection, and radiation. And also you can make use of combination of all these three as well. So we will be able to understand and prove what exactly is the temperature at that particular location. And then have a visualization of the impact of the fan. So here we can see how exactly the air is being recirculated inside the enclosure. And here also we can see how the air is being pulled in from the environment and pushed it towards the end of this uh, cabin. So here is the radiation model. You can see the appearance as well. So you can have the radiation appearances in the sense of how exactly is it looking out in a physical model, because that affects the radiation. What is the radiation observant factors are very much important. So you can apply such type of factors into the analysis and then see the real world physics behind it. So determining the human comfort. So this is also one of the important phenomena where you will be able to understand whenever we talk about AC. So how many people or what is the percentage of people that are dissatisfied with this particular temperature zone, and where are the cold spots, where are the hot spots inside a room. So all these comes under the human comfort modeling and in the part of HVAC. So here we can see here we have the vent and there is a lot of recirculation zone over here, and here is a hot spot. So here is the hotspot where the cool air is not able to get into that region, and there will be a lot of people who will be dissatisfied with this particular configuration of an air vent. At the same time, the people who are sitting at these zones will be feeling too cold, and they also will be dissatisfied with respect to the too much cold around their environment. So this is how we can make use of this particular tool and optimize it so that everybody is going to feel comfortable in the particular domain. So next we have fluid dynamics engineer and structural combination, that is nothing but our fluid structure interaction. So here we can see we have this particular external air, and this is the main part which we can see the fluttering. So that is due to the fluid structure interaction where we have combined both CFD solver and FEA solver. So based on the loads on CFD solver, the FEA solver is interacting. So basically the loads, the pressures and the forces that are being developed inside the CFD solver were acting as a inputs for FEA solver. Now when we talk about the design for injection molding, so whenever we talk about here, we can clearly see the short conditions. Whenever we have a mold, so we have first things first, we have to understand whether is it providing me any manufacturing defects like well lines, air traps, what is the cooling time required, what is the fill time required, and is it uniform in the flow front or not, what are the fiber orientations. All these make a lot of sense before we invest any amount of money or time into the plastics injection molding. The moment we see any of these defects, it's pretty sure that our particular product is going to fail in certain tests and we have to remodel it once again, and we will be investing a good amount of money and time onto the process for doing it again and again. So this is where the plastic simulation tool will help us in understanding all these defects and optimizing to the best possible way so that we can avoid any of the challenges. We can anticipate and avoid any of the challenges that we come across. So here we can see this is the full model, and when we have a short conditions, here we can see what are the final outputs. So this is how we can see the filling time. So we will be able to understand what is the amount of fill and what is the and location of the gates as well. So here we can see here this is the gate location and here it is the gate location. So which one is faster? Which one is taking less time? Which one is giving us less amount of pressure in order to fill the analysis? So all these factors can be evaluated, and there is something called as advisor as well inside the solver. So this particular advisor will help you in understanding your process, whether to go ahead or not. Just like our traffic lights, there will be red, orange and green. The moment you see after the analysis, the moment you see it's showing the green light, then it is absolutely fine to go ahead with the set of boundary conditions. If it shows orange, then it is giving you a warning saying that certain things have to be addressed before you take it to the physical world. If it is shown red, then it is absolute failure, and you have to mandatorily make the changes to make it viable for the end users. And here we can see we have one more gate placed at this particular location, and which is taking more amount of time compared to that of others. And now we have multiple gates. So when you have multiple gates, how much percentage is provided by the gate 1, coverage is provided by the gate 1 and gate 2. Such types of analysis also can be obtained. So here we can see the uniformity of filling, and here we can see the lines of it. So the isolines and the filling contours. So here we can see the moment we started our molds. So what are the well lines that we are going to get? So here we can see the well lines. So these are the places where the structural integrity of our molded component will be very weak, and it will be easily breakable at that particular location. So here are the sink marks. So if at all there are any thick edges or the thick components, thick part of the component, there we will be able to see the additional deposition of the plastic material, which will be providing not a proper aesthetic look. At the same time, since there will be a lot of cooling time and the fill time also increases drastically, which is not at all viable and suitable for the commercial purpose of our plastic model. And then you can have the layouts investigation as well. So if you want to make use of the different runway systems and you want to fill the molds at the same time. So how do we do it? How many number of molds can be optimized? So here we can see that basically what exactly we are doing is balancing of our runner system. So we can simulate and we can see how exactly it takes, and with the same particular amount of time, whether is it filling both the molds or is it increasing or is it doing only one. And if that's the case, let us increase the size of the runner system or increase the pressure, increase the velocity of it in order to address all these challenges. And also how many number of gates do I need to solve this particular problem. So here we can have the optimization of the cycle time. So here we can see that's a material and the cooling system as well. So how exactly the heat that is being dissipated over the period of time during the analysis is taken by the cooling system. Is it functional, or if not, what needs to be addressed? Do we need to change the cooling system or the fluid? All this we can take these decisions in the earlier stages of modeling itself, so that once we are ready with our complete model, we can go ahead with the approvals and the physical products. So here we can see the warp and the part deformation. So these are the two key factors that is a huge problematic for every injection mold engineer. So we cannot expect or we cannot evaluate what is the percentage of warpage that is going to happen the moment the product gets cools down. So for that case, we will be able to understand what is the percentage from the solver with its final shape, and based on that, we can do the little bit on the dimensioning front in the CAD and rerun the analysis. So that with this particular additional dimensioning provided, we will be able to get the final product, final shape of the product to be the what we are expecting at the real world. So that is what exactly we are going to see. So what are the tolerance values that are going to be employed from the designing activity itself? So in order to summarize the applications of plastics, kinematics, structural FEA part of it, and the computational fluid dynamics part of it. So MODSIM enables us to the time to solution will be much lesser. At the same time, reliance on the simulation will be much higher. So here we can see the graph. So since 2010, where Dassault System has launched this particular approach of modeling and simulation, we can see over a period of time there are lots and lot of people and the companies are getting adapted to the system where they will be able to reduce their time to market and complete new product development cycle to the greatest possible extent. So makes innovative product before your competitors, reduce cost and time of physical prototyping. Just go with the virtual testing, and if at all, if there are certain certificates where you need to address your physical product mandatorily. Even in such cases, instead of going for multiple iterations, by making use of simulation, you can go once and get your certification done. So that way, your virtual testing will help you in reducing the effects of your certification costs as well. And in few of the cases, since the solver that we were discussing about is Abaqus, Abaqus reports are very well valid in most of the certificate organizations. So you can directly provide these certifications as a proof that your particular model has been validated by making use of SIMULIA Abaqus. So it is very much important for each and every one of us to accelerate the product development so that we are on par with our competitors and improve the product quality. So instead of selling the product and getting the feedback and then changing the products or improving the product quality over a period of time, what if we provide the best product quality in the beginning itself? In that way, we are way ahead of the market. So that would be the best strategy for our business as well. So make informed decisions due to the collaboration between the modeling team and the simulation team. There will be a complete collaborative environment where people will be discussing each and every instance of it. So the simulation team will be in interaction with the modeling team and the modeling team will be able to understand the defects, understand what are the challenges over the simulation that people are going to get, and based on that particular input, they will be able to model. Instead of just over the word discussion, you can have a proper visualization as well. So tool to design better product. So as I said earlier, it is SIMULIA Abaqus. It is one of the best tools that is available in the market, and it will definitely make our designs to be a much more better. So this way we will be able to, this particular analysis tools will be able to address each and every domain. So starting from aerospace to the life sciences as well. So all your MRI scans, X-rays, microscopes, all these undergo rigorous virtual testing. When we talk about take a best example of our mobile phone. So the moment we talk about our mobile phone has close to 15 antennas. So it is very much important to understand what is the radiation that is emitted by the mobile phone. That is electromagnetics part of it. And then nowadays we are seeing the mobile phones are very much compact in size. So how exactly is the thermal capacity of our mobile phone? Whether is it able to cool down? If not, what exactly can be done? Can we implement heat pipe? Can we implement a fan? Can we implement any other vents so that the heat can be dissipated from our mobile phone to the outside environment? And then what is the structural integrity of a mobile phone? What is the drop test? And there is a 3-point bending test as well. A lot of people will be putting their mobile phones in the back pocket, or even we will be putting it on the desk, we will be putting on our backs, where there will be other products which will be falling on top of our mobile phone. How exactly is the deformation that is going to happen on our mobile phone, and is it able to withstand such particular stresses and the deformations? And then a lot of our mobile phone has plastic parts. So is this plastic parts manufacturable or not? If it is manufacturable, how easy it is? If not, what are the difficulties, so that we can address now itself, and then we can go for the final product. So if we consider a small mobile phone that we purchase for 10 to 15,000 rupees, there are lots of tests that are going on behind the scenes. So just imagine our products where we will be building machineries, automotives, each and every product. So these simulation tools will help us in identifying all these challenges well in advance so that our products are going to sustain in the market for quite a long period of time. So we are up for a Q&A session. So if you have any questions, I guess you can just type it in this particular questions. Okay, so in order to address about meshing, so there are yes, the 3D experience tool is an absolute beast when it comes to the meshing as well. So this 3D experience SIMULIA tools has built-in meshing techniques, processing techniques, and the post-processing techniques as well. So whatever we get, based on the there are a lot of misconception whenever we talk about simulation tool saying that we need a preprocessor separately. That is completely not required when we talk about 3D experience SIMULIA, as we have one of the best pre-processing tool embedded into our processing itself. I hope I answered your question, sir. And then yes, simulation can be used by design engineers as well. That's the main motto of our MODSIM approach. So in the previous slide where we have discussed about like couple of years back, I would say a decade ago, there were myths saying that the simulation has to be performed by so and so engineers. They need certain specialists in order to perform. That's not the case now. Everybody is eligible and has a capability to understand and to run the simulations with the help of MODSIM approach. Yes, we do provide training as well. So once the license procurement happens, we will be able to provide the complete training on the tool, starting from once again pre-processing to the post-processing. Yes, so there are few startup programs available. So you can get in touch with the respective teams in order to get the insights about what are our startup programs, where we will be able to support you with the complete modeling and the simulation bundle packages. Okay, so thank you all for attending this webinar. Hope the webinar was helpful for you. If you have any more questions or maybe in the future, you can get in touch with us and then we can have a one-on-one discussion on the same. Thank you.